A very good morning, my dear students. Today we will solve a big game method problem 2. Okay, so before starting big game method problem, let me understand what is big game and what are the rules and regulation to solve that type of problem. Okay, so it is a method of solving the linear programming method. So it is also a technical method to solve all the simplex problems, and it is one of the oldest LP technique. Okay, so big M refers to a large number that associated with an artificial variable. So we are adding this BM with an artificial variable. Okay, so the big game method is introduced a surplus and artificial variable to convert all inequalities into a standard form. Okay, so add first you have to add the artificial variable in the model to obtain the feasible solution where the sign is greater than equal or equal sign. Okay, the value of m is assigned to the each artificial variable. So the m value should be it is like a coefficient of artificial variable. Okay, so next to solve the artificial variable points to be remember, these are the 3 points should keep in your mind. Okay, solve the modified LPP by using simplex method until any one of the three cases may arise. So if if you got this cases means you will get a problem is a solution, that is optimal solution. Okay, now if no artificial variable appears in the basis and the optimal condition are satisfied, so this is one of the condition. If at least one artificial variable in the basis at the zero level and the optimal condition is satisfied, and third point is if at least one artificial variable appears in the basis at the positive level and the optimality condition is satisfied, then the original problem is has no feasible solution. These are anyone, if you achieve these means the given problem is correct. Okay, so we are going to solve now the problem begin method. Okay, the problem is given like this. In the question they may ask you solve the following LPP by using a big game method. Okay, use simplex method. Okay, so procedure is same, that just we are going to add the surplus artificial variable along with the quotient m. Okay, question is maximization is equal to z of x1 plus 5x2 subject to a constant of 4x1 plus 4x2 is greater less than equal to 6, x1 plus 3x2 is greater than equal to 2, and where x1 and x2 should be greater than equal to 0. Okay, so to solve this, so I've told earlier also many times, if it is less than means you add the s1, if it is greater than means you subtract s1. Okay, so here first equation is 4x1 plus 4x2 plus s1 is equal to 0. So x1 plus 3x2 minus s2 is equal to 0. We are subtracting here because sign is greater than for the second equation. Understand? So in the first equation it is less than is there, we are adding s1. Okay, so where s1 stands for slack variable and the negative sign indicate the surplus variable. So okay, next, so after finding this you have to modify the maximization equation also. What you got in the surplus variable or slack variable, just to add into the maximization equation, that is z of x1 plus 5x2 plus 0s1 plus 0s2 minus of m into a1. So I told m is a big, that is a large number that is always with actual variable, that is a1. Okay, again just to modify that equations, 4x1 plus 4x2 plus s1 is equal to 6, x1 plus 3x2 minus s2 plus a1 equal to 2, and where x1 x2 s1 s2 a1 is greater than equal to 0. Okay, to solve this normally we have a simplex method table. Okay, so construct simplex method table. So here first column basic variable is there, and basic variable coefficient we have to add in second column, and third row that is x equation coefficient x1 x2 s1 s2 a1. Okay, so top you write their coefficient, x1 coefficient is 1, x2 coefficient is 5, s1 coefficient is 0 0, a1 coefficient is minus m. Okay, so here the equation xb is equal to, it is equal to 6 and 2. So x1 equation is right, quotient is 4 4 1 0 0, and second equation is 1 3 0 minus 1 1. Okay, so once you calculate, once you put all the values in this equation, so you will calculate what zj value. Zj value is equal to what, this is 0 into 4 plus minus m into 1, you will get minus m. Okay, like that you calculate all the zj values. After calculating this, calculate the cj minus zj value. So cj value is given the top, and zj values you calculated, that is 1 minus m is equal to, you will get m plus 1. Okay, similarly you calculate the entire row. Okay, so you will get m plus 1 3m plus 1 0 minus m 0. Okay, now once you stop this, you check whether the given solution is optimal or not. How to check? For maximization problem all should be 0 or negative values, but here some well cj and zj values also we got positive value. So I can go for construct the second simplex table. Okay, in second simplex table to go, so before that we have to here do some calculate the key intersection element. So cj minus zj value is highest positive value is 3m plus 5, you select that particular column, that is 5 x2 4 3 minus 3m, select that one particular column, and here again you divide that selected column by xv values. 4 by 6 is equal to, you will get 3 by 2 here, minimum ratio. Okay, 3 by 2 is equal to, write here 2 by 3 is equal to, write 2 by 3 as it is. So in this yeah, minimum value is 2 by 3 is there, select particular row. Okay, so here 3 is a key element row. Okay, so that you have to remember. So if you construct second table, so that x2 is entry and a1 is leaving, right here s2 and x2 in the b column, the second table. Okay, s1 and x2. Okay, so I found here s1 and s2. Okay, so next, so that selected key element row, you have to divide the each value divided by key element row. So for 1 by 3 will get in the here. So here just you check here, here 1 by 3, here this is 3 is a what, 3 is nothing but the key element row, so that particular row have to divide by 3. 1 by 3, 3 by 3 is equal to 1, 0 by 3 minus 1 by 3, 1 by 3, like that you have to write here the x2 in place of x2 row. Okay, and for this previous case, this s1 values, use the formula. So I wrote here formula, r1 is equal to old value divided by old value, here wrote a new value, that is r1 old divided by 4 by 3 equal to r1 is equal to old divided by 3 by 4, you will get otherwise my formula, that is old value is equal to minus key value, corresponding key value into corresponding column divided by key element. Means if you use that formula, means you will get 10 8 by 3 0 1 4 by 3 minus 4 by 3, and this side is 5 by 3. Once you calculate this, again you calculate the zj values. Okay, zj value is equal to what, this 0 into 8 by 3 plus 5 into 1 by 3 will get 5 by 3, like that to calculate. Once you calculate the zj values, go for cj minus zj values. So top is given cj, bottom is given zj values. So 1 minus minus 5 by 3 is equal to, we will get minus 2 by 3. So like that you are solved, you will get. Again, to check the solution is optimal, you need to know all value should be 0 or negative, but here one value in 5 by 3 is positive is there. Again construct the a third simplex table. Okay, so here constructing simplex table here. Okay, here s1 is here you check it here, s2. So s2 and here last 5 by 3 is the highest positive value, and this is 5 by 2, select that particular row and column. So here s1 is leaving and s2 is entry. So here third simplex table is s2 and x2. So similarly use that formula, right here is cb coefficient, and solve what you solve in these two method, construct this third simplex table, you will get this c value. Okay, zj value you get 0 by 2 plus 5 by into 1, 0 into 2 plus 5 into 1, you will get 5, like that to solve. And cj minus zj, again you subtract from cj to minus zj values, you get minus 4 0 minus 5 by 4 0 minus m. Solve this table, you got same what we did in the previous. Okay, same procedure you follow. So you will get finally cj minus zj values all should be 0 either negative. So you check it here, minus 4 0 minus 5 by 4 0 minus m, all values are negative either 0. So stop here, the solution is optimal, and answer is at x2 is equal to 3 by 2, and x1 is not there, so here write 0. So at this stage the value should be the solution is optimal, and maximization is equal to 15 by 2. So here I wrote 15 by 2. Okay, so same formula use, you will get this 15 by 4. Okay, so this is about the big game method problem. Okay, so I hope you understand this problem. Thank you.